So first, I wanted to make a quick introduction. Again, hello everyone. Welcome to the 16th IIOA webinar. I'm Kui Shuangfeng, the Vice President of the IIOA, and also the lead for the IIOA webinar. So today, it's our pleasure to have Dr. Nicolò Golinucci. So he is a researcher and also entrepreneur in the field of sustainability and industry ecology. So he holds a PhD in energy and nuclear science and technology from Politecnico di Milano, where his thesis focused on the role of industry ecology in evaluating strategies to reduce greenhouse gas emissions. So during his doctoral studies with the SESAM group in the Department of Energy of the university, Nicolò, along with the colleagues, they developed this Mario model, which he's going to introduce today. So now, currently, Nicolò is the administrator and also a senior researcher at eNextGen, a startup with a particular focus on carbon printing for companies looking to implement sustainable practices. So we will now let Nicolò have the floor. Yeah, floor is yours. Yeah.
Thank you very much, Professor Feng. I'm now going to share the screen because I think you can all hear me well and see the screen. Yeah. Just a second. Yes.
Yeah.
Okay, great. So thanks again for the introduction, and thanks again for the opportunity for me to share what is the result of years of working together with colleagues in trying to bring something useful to the input-output community. So the objective of today is to try to go from knowing nothing about Mario to doing something, and the second part of the webinar will be like a tutorial. Okay, so let's start. And I would like to start with an introduction from myself, but it was already said everything. I'm Nicolò Golinucci. I hold a PhD, and now I'm working for a spin-off of the university in which I had my PhD, which is Politecnico di Milano. And the company that I'm today representing calculates companies' carbon footprint with a particular attention to scope 3, which is something that we can investigate with input-output and life cycle assessment techniques. As I was saying, the result of what I'm showing today is also the result of the research group in which I had my PhD, which is the SESAM group. And in particular, Professor Colombo and Professor Rocco supervised this work that was brought to life by me and my colleague Lorenzo, and particularly my ex-colleague Amin, who is the lead developer of Mario. Okay, so now after introducing myself, this was something useful to explain why we create Mario. The idea was to build on the research experience of the SESAM group. So the group had multiple years of publications and research on input-output, and most of the time the work could be, of course, on many different topics, but there were common ground in the methodology. So during my PhD, which started with this particular publication that was on carbon leakage, I asked myself, but why should we start every time from scratch? Maybe using Excel or something even more sophisticated, but most of the time needing to start from the ground. So I, together with the colleagues again, asked myself, why can't we build something that is transparent with respect to the database being used, and that let you do the typical practice that every input-output modeler do does all around the world. So we started trying to bring everything into a repository. We started from an Instagram story and a piece of paper during basically the beginning of the pandemic, so 4 years ago. And after some inspiration on both coding and also on how to present the packages, we end up also having a logo, which is inspired by this beautiful chart that was provided in a China carbon emission report that is showing all the emission embedded in trade. So something very peculiar of what you can do with input-output. And this also brought the inspiration for the logo, which is this one, and that defines MARIO, which stands for Multifunctional Analysis of Regions through Input-Output. Of course, we add this name due to the similarities with multi-regional input-output, which is for an Italian very hard to say and very close to the very famous name Mario. Okay, so that was at the end of the day the real reason behind the name, together with taking advantage of other more famous Marios that can link the project also to Italy. Okay, jokes apart. It's now time to speak about the package itself. So what is Mario? Mario is an open Python-based objective-oriented package that has the objective to ease input-output analysis practices. So we will see what does it mean, what does Python package mean practically, and in practice, we can handle through Mario virtually any input-output or supply-induced table. And we can transform supply-induced tables into input-output. So the starting point of Mario, the very first function I will show you and that you will use if you are going to use Mario, it is a parsing function. What does it mean? A parsing function is reading a database. So letting Mario read a database. Now we are in, I think, a period, having attended multiple of the last input-output conference, a flourishing of tables. What we are trying to do in our project is to try to, stay on the path of this flourishing period of input-output tables. So trying to let Mario read all the new projects that are coming. At the moment, Mario can read IIOA database, ExIOBase, Eurostat, and the hybrid version of ExIOBase, so also using multiple units, not just monetary units, but also hybrid units, as we say in the community. And you can even read your own TXT or Excel table. You just need to rearrange a little bit your table before starting, but in principle, if you have an input-output table in Excel, you can use Mario to ease your work. So once you have your input, which is the database itself, you are ready to process the database. What can you do with within this framework? You can perform shock analysis, and you can rely on multiple scenarios that are automatically created every time you run a shock analysis. And then you can describe even a new supply chain. You can use a dedicated function to add multiple sectors, commodities, or activities to your table. And in this way, you can even performing hybrid LCA. Everything is documented, and you can find those links that we will share after this webinar on GitHub, on Zenodo, and we also have a dedicated Read the Doc website with full documentation, but we will explore it later in the tutorial. The output, once you have understood through the documentation how to use Mario, it's any kind of result that you can think in an input-output analysis of any kind. You can even use Mario together with some more sophisticated models in case you are using, I don't know, I'm thinking about the word trade model, for example, or even a CGE model. In principle, you can use Mario in your code to ease some of the parts that are common to all those models. I will stress this more later on, but we also have now a publication that you can quote in case you're using Mario for your research. We publish on the Open Research software, and some of the topics of the paper will be shown now directly in this presentation. So now that we know what is Mario, let's make a step back. This step back is basically trying to understand what is Python. I don't want to give this for granted, because I know that a lot of researchers have different researcher habits and different tools. So why Python? First of all, I want to share with you this this video that I going to, and we will start from 2010. This video is taken from an analysis that is showing basically the number of users, I think, by programming language. As you can see, you can still see R, which is very used. I also know about a package from Professor Ewings that is using R to perform input-output analysis called RealIO. And I also know that economists in general, I have an engineering background, use R more than Python. But as you can see, very recently, Python is skyrocketing in terms of adoption from a point of view of programming languages. And this is the picture that you can also see here. So why Python? Simply because it's the most used programming language all over the world. So in case you are using Python, which is more probable than anything else, Mario and other packages actually can help in your everyday work. Again, but we need to define a little bit more, because again, I don't want to give for granted that you are a Python user, and you can get confused by the very different names that you can find: anacondas, pythons, spiders, and even planets. Okay. So what is Anaconda? Anaconda is a distribution of Python. You can think of an application that you can download and install in your computer, in which you find specific programs that can help you using Python or R, for example. So Python is a programming language that can be accessed after having installed Anaconda or something similar. And again, is a programming language. It's an high-level programming language, which means that it's easier than many other programming language, which is closer to human communication. And Spider, so another animal, is an interface that you can use to actually write and ask your computer to run the Python code you're writing. Okay, this is clear. What is Jupyter? Because you may hear this also in the presentation. Jupyter is something very similar to Spider. It's again an interface to use code, but you can find it and use it as a web application. So you can use even your browser to use Jupyter and to run Python. Okay, much more. Talking about Python, you can even use Visual Studio Code, which is getting more and more users, I think, recently. And the more you get into code, the more you want to use Visual Studio Code. Now I'm personally switching from Spider to Visual Studio Code. And it's an editor, again, something, an interface in which you can perform code in many multiple ways. Okay, now another definition of something which is super important. Because if you want to use Python, you want to create an environment. An environment is an island, you can imagine, in which you can find multiple packages. Okay, so before starting using Python and all the packages like Mario is, like Pandas is, like NumPy is, you need to define your environment. And we will do it together. And after you create an environment, you can start installing multiple packages within the environment. Okay. Now we have all the definitions that we need to understand and the rest of the tutorial. So why do we need an open source package for input output? So the real reason behind what we're doing is trying to give some help in the fact that multiple times you do the same things while you cannot replicate it, because every time you change one tiny thing, you need to run again everything and to build again everything. If only we have an integrated tool that supports model generation, we can save time in coding and have more time for thinking, while reducing margin of errors and increase flexibility. Ideally, this could even work as a standard somehow to for input-output studies, because it's very easy to use this package and to perform the same things with different databases, so different results. But Mario is not the only input-output tool you can find in Python. And this slide is taken from the 2023 Input-Output Conference. We had a special session on open source together with Konstantin Stadler, which is the developer of PyMario, which is currently the most used Python package for input-output that we highly recommend, and that we also have an handshake protocol with. So now if you use Mario and you want to move to PyMario, it's very easy. But there are multiple other packages that are useful for the input-output community and for the LCA community. Unfortunately, even if practically all of these packages are open source, talking about open science is much more than this. Because most of the time, a package can do something, but maybe cannot do what you need. And most importantly, because it's very hard to switch from one to the other, because maybe you have one solution in one package and another solution in another one, and usually you have to write a lot of code to be able to mix the two. And moreover, when you start coding, you want to, put the hands on the code, and maybe you are tempted to write everything from scratch. This is also something that happened to us when we started Mario. In our perspective, the possible solution to this problem is to have integrations, to have documentations, and to have teaching. Okay, so the integration is basically being able to talk, to let the package talk one with each other. And the teaching is a moment like this one. And even YouTube tutorials like this webinar will become are even more useful, because you can stop the recording, do again what I did, and try to perform the same. So again, before going into what Mario really does, what is an open-oriented programming class? Think about humans as a class. And you have properties, you have an age, you have a sex, you have a nationality, and you have functionalities. You can do things, you can travel, you can migrate. Let's take two very different people as an example. So me and Einstein, okay? And think about people as instances. Very different person, different jobs, different status. And if I want to migrate, so if the class human that I'm representing try to perform the function migrate, you can have a filter and a blocking. In case you are alive, you can. In case you are not, you cannot. Okay, that's a very silly example, but let us understand how instances work. And the very same thing can be done instead of a human for an input-output database. And now we're coming to Mario. So what can you do? You can take an input-output table while you are maybe in a brainstorming session. You don't know yet what to do. You want to understand the table. And in order to do that, you want to aggregate the table. You can do that with Mario very easily through an Excel interface we will show. And you can end up with an aggregated table. Or, as I was saying, you can add activities and commodities, again, with an Excel interface, very easy to use. And you can implement shocks. So moving from a representation of the Z matrix in coefficients, changing something in the Z matrix, and having a new version of the whole set of matrices, which is the database, and performing scenario analysis. Okay, everything is supported by Excel. So this is the core structure of Mario that you can see also in the paper, and that we will use to explore a little bit what can you do. You can handle any unit of measure, not just monetary units. Now we see more and more hybrid units table that are very useful, and you can handle, for example, the hybrid version of Exaiobase. You can handle scenarios, and once you have those scenarios, you can perform calculations. So you can move from flow tables that here I'm representing in a supply and use fashion. You can sum all the rows and getting the production. You can take into account value added, so monetary extension of the table, and not monetary extension of the table, which are called satellite accounts. And for the nomenclature, we took advantage of the thermodynamics that is common for and useful for engineers, switching from flows to coefficients, just moving from capital letters to small letters, being specific those functions with respect to the previous one. So uppercase, we have matrices of absolute values. Lowercase, we have matrices of coefficients. That's the basic idea that we are using for practical issues. And then you can choose your assumption. Now we are supporting industry-based technology assumption for supply and use tables. But in principle, after performing, you can perform a shock analysis in any of those tables. And through a function that we will show, which is called shock calc. And you can move from supply and use to input-output tables through all the 4 main methods that are also explained in the Eurostat manual. Then you may not like our terminology, because nobody likes anyone's terminology, and especially if you're using W instead of L as the Leontief coefficient matrix. But in the new version we have of Mario, you can change your own terminology, because this is we have seen that this is a big barrier to start using the package. But you can change all the names of the variables, which are the matrices of the table, so that close to what you are familiar. Then just a deep dive on now we perform the new the adding of sectors. You can basically add rows and columns for every activity or commodity that you want to add. And this is particularly useful, again, if you want to use hybrid LCA. And then there are some built-in visualization that can be useful in case you want to understand the basics of a certain table. And so you can have the representation of gross domestic production in a tree map, or a bubble chart for having an understanding of the CO2 and the employment together with GDP. And you can perform this quite easily with Plotly, which is another package that you can find in Python that we suggest. And taking advantage of the scenario parameter, you can perform multiple runs of the same table, also projecting in the future some of the changes that are occurring in your research, in your modeling exercise. And this is, for example, what we did in a research in which we were looking for the carbon emission payback time of an investment. So we use Mario and specific data for that case, and specific input-output table, and we perform this analysis looking at the flow by year in terms of CO2 emission with respect to a baseline. This is just an example of what you can do. Okay, we are now finally close to the end of this first part. And so now we start with the tutorial. The tutorial will focus on installing Mario, Spider, so that we can perform the tutorial of Mario. We will start from Anaconda, so I will skip the download and installation of Anaconda, which is something very easy that you can do simply by saying download Anaconda and in Google, and you will be done. I will skip this part because it's a little bit too long. So we will see together the installation of Mario, the installation of Spider, and the use of Mario. So now it's time to switch to the Anaconda. So just let me show you what you should expect. So once you have installed Anaconda, you simply need to go in your computer and type Anaconda PowerShell prompt. Now you cannot see because it's in the other screen, but you simply have to click on it. And once you're done, you will see something like this, a terminal. But don't get scared because it's so easy to do what we need to do. And in order to understand what we need to do, I'm now showing to you the documentation of Mario. Okay, and it's here behind. Okay. So if you go in the documentation of Mario that I will share with you, you will see there is an installation. If you write on it, you will see how to install Mario through this Anaconda prompt. And in order to do so, you just need to write those words, conda create -n Mario, I will call it Mario env. We are creating the environment, you remember? So a place in which we will put all the packages that we need for our research. And I will call it Mario env. Here is suggesting to call it Mario, okay? And I need to say that I want the version of Python 3.10. If you simply copy and paste, you will see something happening in your window, and this is going to be very easy to perform. Is asking what packages do you want to install? Simply say yes, because it's automatically understanding what is really needed. Okay, this is this takes some seconds, as you can see. And once you have created your environment, it's time to go in the environment. You will see here that I'm currently in the base. Where I want to go is to go in the environment called Mario. So conda activate Mario. Actually, I call it Mario env. And you will see that instead of base, now you see Mario env. And now it's time to install Mario. And you simply need to say pip install Mario Py. This will take some seconds, and actually some minutes, couple of minutes. Meanwhile, I will introduce to you the database we will use for this tutorial. Again, as I was saying, and if you go here and you write parse, you will find all the functions that are inside Mario directly in this website. And you will see all the things that you can read through Mario. You can read your TXT table, you can read eOra, you can read Eurostat supply and use table. But today we are going to work with the monetary version of Xiobase, which is one of the most used tables. If you Google Xiobase Zenodo, you will end up in this page. And in this page, you will see all the Xiobase versions and also all the different years that you have in Xiobase. You know that you have a time series. For this exercise, I'm going to use input-output table, industry by industry of 2022. okay, just for an exercise. And you can find it here, you can download it, and you will end up with something like this. A zip folder, okay? You don't have to unzip the folder because it's something we don't need. Mario will read from the zip folder without using extra space in your memory. And so basically you just need to download it, and you will find it in your folder. Okay. Once we get into the database, you will see that you have all the matrices that you find in any multi-regional input-output table. We are going to use a multi-regional input-output table. And okay, here is done. We now also need to install Spider. So while we talk, I say also pip install Spider. In this way, we can finally being able to use Mario. So as I was saying, this table is a multi-regional table. We want to read it. We want to explore it, maybe computing some footprints. Then we will aggregate the table. And once we have aggregated the table, we can print it in Excel. This is very useful when, again, you want to have a conceptual model of your more sophisticated model. And in this way, you can interact a little bit easier with it. Okay, now I think we are very close to have everything installed as expected. And once we, in order to understand if everything is done, you need to wait till you have back your row referred to your environment, because we are currently in this environment. And every time you are going to work, so we are done. Let me open Spider by simply typing Spider. And every time you are going to open this your Spider, you need to do it from your environment. Okay, so always remember to say conda activate Mario environment. Oh, finally we have Spider. This is Spider. I will try to zoom as much as possible so you can read. And we now need to write some Python code. Don't get scared again, because it's very, you will see, it's really a matter of understanding how to refer to paths, and that's it. So where is your file? So let's start. Finally, I want to, first of all, import Mario, and I want to save this file. And so let me open a new file and let me save it for the first time. I will put this file in my desktop in a folder that I prepared for today, and I will call it tutorial. Okay. In this folder, I already have the database. You cannot see it, but okay, this is the situation. We have the file. We also need to say to Spider that we are working in that folder. You simply need to go here on the top, clicking on the folder, selecting, and you are there. So in this way, we are finally in the folder that we want to work. So now, again, I want to import Mario as the very first thing. In order to run what I write on the left in the console I have on the right, you have multiple ways. And I have no time to go through it, but it's very easy. You just need to understand the very basics of Python and Spider. So I can run with F9 a specific line of code. I've just imported Mario. And now that I've imported Mario, I simply need to say, where is the path of the XIO base database. So let's go and check. We are already in this folder, which is called IIOA Webinar. So I simply have to say the name of the file that I'm now copying between apices using the R at the beginning. This is due to the fact that I'm using Windows. And I have to say the format, so .zip. That's it. That is what I need to do. And now I'm finally ready to read the word. So the representation of the input-output table, which is the word, using Mario parse EXIOBase. As you can see, if your installation was good enough, you will see that Spider is already suggesting you what does this function needs as inputs. So as you can see, he wants to know what's kind of table. You know, we are handling both input-output table and supply-induced tables. What is the unit of measure of the table and where it is? So what's the path? So I can easily say that the table is EOT, input-output table. The units are monetary with the capital M. And the path, I already said the path, so I can say path Exio. Once I'm done with this, I need, of course, to read where is the path. I can run this line of code. We are reading a gigabyte of database, but this is taking usually less than 30 seconds. We will see how fast it is. This depends also on your machine, okay? Because of course your RAM is a limitation to reading super huge databases, but this is how you can work. So once we are done, and this is done, we can finally enter into the specific tables. So we can read, for example, the final demand of Mario by simply saying word.y. Okay, again, this is the terminology that in principle you can change, that we are using in Mario and that you can see here in the documentation, clicking terminology. So if you go here, you see final demand, the name is Y. You can also maybe already refer to it with F, but this is the final demand. And once you pass it to a variable like I have just done, and you run the code, you end up with a pandas data frame. Okay, pandas is probably the most used together with NumPy Python package that is helpful in data handling. So we built on pandas so that you can use Mario through it. And as you can see, these are all the inputs. Maybe you cannot read well, but this is the Y matrix. And if you're interested in some other matrices, like the satellite account matrix, you simply have to say E, or even you don't have to use the same letter, but I'm using this for simplicity. You can use the letter you like. And you can now have a look at all the emissions. Okay. I think so far, so good, and also so easy. But what if I want to perform some calculations? What if I want, for example, to compute the footprints of all those satellite accounts? How many satellite accounts are we reading? In order to do so, try to write directly in the console the name of your variable, which here I'm calling word, because at the end of the day is the description of the word. If you do so, you have some information. You have a name that we didn't assign. We have the kind of table. You have the factor of production. You have 1,000 satellite accounts, because this is how you find EXIOBase. You have 49 regions. You have 163 sectors. That's great. But again, what if I want to compute the footprints of this table? Nothing more easy, because I just need to say word dot, what's the name of footprints? F, footprint coefficient matrix. And if you do so, you will see that Mario is automatically starting from the flow matrix, computing the coefficients. He needs E and the Leontief matrix in order to compute the footprints. This is one of the most time-consuming tasks if you have a super big database, because you need to invert the matrix, etc. But it's simply a line of code, and you have your footprints. And once you have your footprints, then you need to know, and here we have it. We simply need to know what is the satellite accounts that we want to look at. But one problem is that usually you don't really know precisely the name of your satellite account, the name of your sector, the name of your region, and that's why we implemented a function called search. So let's, for example, say that I want to know the carbon footprint of the electricity sector in the USA. So power sec, this is the name I'm going to give to this list, will be the list of sectors that are electricity sector. So I just need to say word.search. And I need to pass, first of all, what's the level in which I'm looking at. I will look in sector. So I need to pass sector. And then I have to pass the string of what I'm looking for. So I'm not looking for something specific. I'm looking for electricity. And if you do so, you will end up with all the power sectors. Okay, so all the sector that contains the word electricity. We also have the transmission and distribution in this case. And so if I want to check the carbon footprint of those sectors, I simply need to say, I don't know, let's find a name, footprint power. I simply have to take the F matrix, which is a pandas data frame, and I can pass and use the terminology of pandas that we are not going to have a lot of time for, and say CO2 combustion air. Of course, you can do the same with satellite accounts. I'm simply saving some time here. And I'm going to say, look at US and look at the sectors that are power sector. If I run this line, I'm done. I have the carbon footprint of those sectors per million euros, because we have a monetary table. And I don't know the unit of measure of this matrix. So in order to do so, I simply need to ask word units. Please, Mario, tell me the units of measure that are in this database. And if you do so, let's pass it to something, to a variable. You will see that you have units for factor of production, for satellite account, and for sector. If you go in satellite account, you will see CO2 emission air, and you see that are kilos, while the sectors are in million euros. So the number we are looking here is kilos per million euros. And you can see here that gas and coal are the most, the one with the highest carbon footprint, while of course the nuclear is the one now with the smallest one. Okay, this is just an example, and you can perform much more. You can aggregate your table, and you can ask Mario to write an Excel file for you. By telling get aggregation Excel, and you can give a name. You can call it agg.xlsx. And if you do so, you have some warnings, but you will see an Excel file that has been generated. Okay, And you see that here I have on the A column the starting point, let's say, and on the B column I have an empty space. Now, we have this for factor of production, for satellite accounts, for consumption category, for regions, and for sectors. So for all the dimension of our input-output table. Now, like in cooking shows, I've already prepared an aggregation for you because we don't have much time. So let me use this aggregation and let me copy paste very rapidly this aggregation. So for regions, for sectors, but you can choose, of course, your own one. For sectors, for factor of production, so for satellite accounts, and that's it. Oh, no, sorry, I forget consumption category. Okay, so this is how you should fill this table, this Excel file. So now we can go back to our, you can save it, we can close, and we can go back in Spider. And now we can aggregate the table. So we can create an aggregated version of the word. So we can call it word agg. And if we can say word.aggregate passing this agg Excel file we are using. I need to say that I want to pass it to a new variable and not to do that in the old one. So I need to say in place equal to false. And if I do so, I end up in some seconds to an aggregated version of our table. As you can see, this is a 6 sector, 3 regions, like the one that we decided. You want to export it in Excel? You simply have to say agg.toExcel. And you can call it aggregated database, always passing the format. And you will see it in your folder. You have the flow, but if you ask Mario also to print the coefficient versions, you simply have to say coefficients equal to true. You also have already your coefficients. Okay. So now we just need to check if the columns are summing to 1. And as you can see here, this is true. So we are, let's say, checking that Mario did his job. Okay, you can do much more than this. Unfortunately, I need to close here because time is running fast. And you can perform much more than this. I will show you all the links. And you can perform at very least what we did in Chile a couple of months ago, a much longer class on this that now is in GitHub. And in this way, you can find your tutorial and you can see that you can even perform shock analysis with the very same approach that we use for aggregating. You can perform sector augmentation with the very same fashion. So as easy as that. So you need to interact mostly with Excel file. Again, thank you very much for your attention. I see that we still have 10 minutes before the hours that was allocated to this webinar. So if you have any question, I welcome you. Otherwise, we are available by email and in the GitHub. So thank you very much.
Hey, thank you very much, Nicolò. This is amazing. I also wanted to mention that Nicolò already gave a training session during our last IIOA conference in Chile. So I don't know if he's going to, give us another training maybe in next year. But let's keep eyes on the announcement, particularly the program of our IIOA school.